shock and revelation. And so I think the best way to describe the shock and revelation is like, you're hired to walk, that's your skill. You show up for the first day, every new job, and you think, oh, I'm great at walking. I can walk fast, I can walk slow, I can strut, I can sleepwalk. And you get there and they tell you, you've been living this whole time. And so I feel like it's not learning how to design, it's almost like learning how to design from scratch. It was there, but it was constrained. And so C-BIP really was this revelation of opening up the possibilities. And I think the best way to describe that is that the thinking is moving from thinking about the built environment as a series of single fixed solutions to more of a set of interconnected, flexible relationships. And so that's the main switch in thinking. And C-BIP, I think the way that they powerfully did it is they paired technique and theory. So typically in the design studio, you might have the design program and you have the theory, but it's not paired with these technical skills you need to manifest this. So there's a huge disconnect. And one of the things that came out of the studio for us was collaboration, and not just the collaboration that was forced upon us by the studio, but we want to embed relationships into our work that force us, the need and the want to put them into them, force us to work with other people, because we can't be the one expert that knows it all. I have to go to the person that knows the development knowledge, the economic knowledge, has structural, sustainability, social knowledge. And I have to understand them and the language to communicate with them and pull it into the work I'm doing. And so the C-BIP was really fundamental in doing that. And all of that led us to, as Laura mentioned, we're at KPF now, which is interesting because Scott talked about how it's the small firm all the way. So we'll see what happens at an extremely large firm. And I think one of the things is they have the resources and the dedication to let us essentially do research and development and then try to implement that process within their office. And so now Michelle is going to show what we're up to.
So as a C-BIP alumni, we have continued rethinking the traditional law of design. So it is no longer responsible to expect to be Superman, the one and only hero to set birth. And we must be more like an X-Men or a collaborative team with diverse powers. We have created X information modeling, or Z, a system that strategically integrates diverse expertise to address economic, environmental, and social problems. Much like Professor Xavier strategically selects X-Men and systematically coordinates their abilities to keep it together. So SIM consists of a library of elements, the categories. So developing information modeling, D, or the zoning information modeling, Z. And the elements they have input data and visualized evaluation, which has a link by translation of accumulated intelligence into parametric relationship. Yes. So, yeah, next slide. So, by reverse engineering and selection and integration of elements, we qualitatively iterate with quantitative visualization of metrics for a range of solutions. So, evaluation leads to looking and calibration of system. This ability to iterate and look back is like time travel. So in Back to the Future, Martin McFly time travels and sees consequences of his actions through an iterative and cyclical understanding of time travel. And he's able to make smarter life choices and alter his future for the better. So through the visualization of iterations, we create a dialogue between the past, present, future in order to test the consequences of our speculations. And through the evaluation, we revise the system. This dialogue leads us to the actions for today that address future challenges. Our first test of SIM was speculation of Logo, Manhattan, or Logo. It is dialogue between how we have developed the problems we face now and how they can be reconciled in the future. So we use the notion of magical realism in order to facilitate a discussion of now tangible futures. So using Google Earth and Wikipedia. For example, this excerpt from Wikipedia in 2015 sets a timeline of So density and value tool is made by creating direct relationship between real estate performer and architectural visualization. Scenarios are driven by the need for infrastructure and public amenity. Yeah. We found database as the level 5.7 FAR generated the value to pay for recreation and mobile with its infrastructure. From there, we are able to visualize the density necessary to pay for various citywide public amenities, such as the extension of certain lines. That tool is paired with zoning information modeling, which integrates environmental performance and design intent with the current zoning resolution to create more contextual zoning. So zoning information modeling is an evolution of current prescriptive zoning towards performative zoning that can respond to the specific and changing nature of the city in challenging environmental, economic, and social conditions. So learning from the multiple features is simply seen. We designed a new city image. Imagine a future where public infrastructure, elevated pedestrian walkways, and water reuse systems. These all opportunities become prepared for the eventuality of the rising sea levels, and thereby align environmental resilience with the commercial enterprise. So now we are working at KPI. We are using projects around the world as catalysts to create the new sim elements. As a global practice, we are able to develop general strategies and refine them through specific application. So each element learns from different tasks. So we need new drawing types to allow for critique of the system. For sim element, we use assumption diagram as means to calibrate the elements and critique from experts and to establish accountability for the designer. By designing, articulating, and managing the scenarios for iterating and sim system, we can get radically different but quantitatively comparable iterations for evaluation. Each will be coded in scenario-based iteration diagram. For urban sim systems, we use low-resolution sim system to test various scenarios in relation to their performance. In this project, view is very important to client. Here we test the impact of view of two new buildings relative to the other buildings in the client's portfolio. We use the same sim system at a higher resolution to create a custom real-time dashboard of metrics that builds in accountability for its building design. For this project, we work with fixed gross floor area and test the designs relative to many metrics such as structural performance, leasing depths, height, and views. For this scenario, we wanted to test a new type, the maximum height type. We tested the various floor areas for locations and rotations. Iterating one variable at a time, we eventually fixed one value based on the qualitative and quantitative evaluation before iterating the next variable. With the flexible system, we are able to jump back in time at any point to change the variables or test a new scenario or adjust our assumption or add a new